Hello, everyone. Good. So today I'm going to talk about synthetic data generation for AI training, with Blender, of course. Okay, my name is Yuan Miao. I'm from China, and I'm working in the autonomous driving industry, which means we need to teach AI driving cars. But teaching AI driving cars is actually a very big subject. So we are going to limit it into teaching AI understand things in driving scenario. Based on an image, our AI should be able to understand what objects is in the scene and its position, location, rotation, velocity. So our AI can make a decision on what to do with this scenario. So I'm going to talk about synthetic data generation, hybrid synthetic data, cloud generation, and some future directions. So the first question is, what is synthetic data generation? So make it very simple. Here are three perspectives to understand this SDJ. So the first one is the machine learning view. The basic idea is that like real-life experiences shapes our human brain, the same way data shapes a neural network, which is AI. And so if we are going to teach our AI to recognize Apple, we want to give a lot of image of Apple. So firstly, if there is data, there is model. If no data, no model. And the second thing is that data quality is very important. For example, in this case, what is this? Yes, for our human being, it's very easy to tell this is a peach rather than an apple. But unfortunately, our AI didn't know that. If we give this peach photo to our AI to learn, the same way as we are giving the apple for learning, the result is that our AI probably cannot tell the difference between the apple and the peach. So this is how data influence neural network. This is how data shapes AI. The second view is the CG art view. For our CG artist, it is very clear that we can create a vision about all possible real world and other impossible world. And this kind of vision is actually a kind of data. The third view is a programming view. The idea is that if we know exactly what to do and how to do, we can make it automatic, and we can easily make a lot of it. So this is what synthetic data do, because AI needs data, and our 3D artist can make data, and programming can help us to make a lot of it. So what is synthetic data? It means programming help 3D artists to make a lot of rendering, and this rendering can be a data for machine learning use. But this doesn't have to be 3 people. As long as you know what data do you need, and you know how to make this data, and you know how to scale this generation process, you can do synthetic data generation. Sounds easy, right? But here are a few things we need to take care before we head into this generation process. And the first concept we need to understand is this variation. When we are talking about teaching AI to understand this table, we didn't mean give 1 billion of a photo of this exactly same table. So we might need to generate thousands of variations about this table, but it's better we didn't do it manually. With the help of Blender geometry node, we can easily generate a lot of variations with few parameters. But when things go to scene variation, there will be more objects. It's more complicated because we need to be very careful about the relationships between these objects. And we carefully code it into our generation process. In this case, if I adjust the shape of the road, the other part in this map will adjust themselves to follow this rule. And we can easily change other part of the map by few parameters. It looks more complex, but anyway, we already know how to do this because this is what we all called procedural content generation. And the second concept we need to understand is the ground truth. So what is ground truth? Talking about giving data for AI training, we didn't only mean give this picture, but we want to give a lot of descriptions about what aspect we want AI to learn. For example, what is it? It's a donut in this case. So where is it? And we can find out that it's roughly in the middle of the image. So it's x-axis 600 and y-axis 900. And how's the size? We can find the size by measuring this white bounding box. And what are those pixels belongs to the donut? In this case, we can see that the pixel roughly in this yellow circle belongs to our donut. And what's the 3D position of this donut? In this case, we don't know. We can only have a guess. But as we can see, this process can be very in-process and can be very objective. As we talked before, this kind of low-quality data could result in downgrading AI performance. Because actually, the pixel in this darker gray area didn't belong to our donut. But Blender Donut didn't have this problem. This is where I start my Blender journey, as you guys. So it will be very easy for Blender engine to answer these questions. So if we turn on the object index in the rendering setting, we can get a perfect image after rendering. And this mask image tell us exactly which pixels belongs to the donut and which pixel does not belong to the donut. And also, if we ask Blender engine Blender donut location, it will give us the exact coordinates of our Blender donut. And one more thing, Blender donut didn't have any limitations. We compare thousands and millions donuts in a scene, and which is impossible in the real world. And this turns out to be a great advantage about synthetic data generation. So synthetic data is extremely flexible because they didn't have this real-world limitation. And we can get the perfect ground truth without no extra spending. And there will be no violation of data privacy. So this is the reason why we use synthetic data for our AI training. But great, how do we do it? How the generation process looks like? It looks like this. We will set up the scene, and we will probably add some stuff in the scene. We might need to do a little bit animation work. And we will set up some other information we need to output. And when we hit render, the work just done. This is the final data we get. As we all notice, this is very similar to our CJ pipeline, except that we have to do it by coding. So here is a programming version about what we just did. The Python script will look like this. We initiate this generation task first, and we will loop the following steps for a lot of times. In each loop, we will set current frame, and we edit the scene, and we render, we find the ground truth data, and we save them safely. So exactly how we are going to do these steps, this will be defined in this part of the code. So now, if we hit this run button in Blender, the generation process just began. But here is a problem, a big problem about this synthetic data generation, is that the index of invest and outcome is very unclear, because actually data is a kind of word we want our AI to learn. As we are training for real scenarios, it's intuitive to think that we want the data to be real as real data. So as a 3D artist, we know what it means. It means a very complex procedural content generation, and it means high quality assets, and it means a lot of rendering. But we find another way of doing this synthetic data generation, that we can invest less, and so we can measure this outcome very quickly. And surprisingly, it works very well. And this is hybrid synthetic data. So what is hybrid synthetic data? Let's look at this video.
Hybrid synthetic data, HSD. A balanced approach to data generation. Hybrid synthetic data, HSD, blends real and synthetic data elements to create enhanced datasets for machine learning models. By augmenting real images with 3D rendered objects, HSD provides a cost-effective way to generate data for rare or challenging scenarios that real datasets might lack. HSD takes real-world images as backgrounds and strategically adds 3D rendered objects as foreground elements. This process, controlled meticulously, allows for the customization of object placement and characteristics, optimizing the dataset for specific AI training needs. The integration process ensures that these elements are seamlessly blended to produce a hyperrealistic image. Unlike fully synthetic data, which requires extensive resources to render entire scenes, HSD focuses on partial rendering, significantly reducing resource demands. This efficiency makes project development, maintenance, and deployment more manageable. HSD's flexibility in data generation and distribution provides AI companies with precise control over their training datasets, making it ideal for applications such as autonomous driving, robotics, and any scenario requiring high accuracy in varied conditions. Hybrid synthetic data offers a practical and efficient solution for enriching datasets, providing the best of both real and synthetic worlds to drive innovation in AI technologies.
Great. So the clear advantage of hybrid synthetic data is that it actually uses less rendering and it looks more realistic. And the scene will be less complex, smaller, so it will be easier for the project management. But here are some key points about HSD, which is the 3D coherency. So let's think about it. How this foreground and this background looks like they are from the same scene. And the secret is that align cameras. So if we set Blender camera position, rotation, and other parameters based on the real camera configuration, we can actually imitate how a real camera looking at this world. So this means we aligned these two worlds. Great, but how about this? It doesn't make sense, right? What happened is that when we putting things in Blender scene, we could put somewhere we should not put, because this place had been taken by other objects in the real scene. So how do we solve this conflict? And there are two general ways thinking about the solution. And the first one is we might find out where to put. We find out the free space so that we can put anywhere within this space. And the second solution is that we find out where we should not put, because this place has been taken by real-world objects. So that means we need the 3D occupancy info in this real scene, how do we get that? How do we get this kind of data? Actually, this is very easy, because actually most of the autonomous driving dataset or robotics dataset have this thing. We talk about this 3D annotation, and it contains the information about what objects in the scene, their position, location, rotation, velocity, and other stuffs. So in order to achieve this 3D coherency, firstly, we need to align two worlds with real camera configuration, and we find the ground truth data through the original dataset. And in our case, we used some AI model inference. And finally, with some human-defined rules, we achieved this 3D coherency stuff with our hybrid synthetic data generation project. Great, now cloud generation. As we talked before, the real generation was conducted by a series of code. And when we hit this run button in Blender, the generation process just began. But here is another way. Another way doing this is that we tell our computer terminal to execute this command, and this tells our computer to open up Blender in background mode and open up this Blender file, execute this Python script, and it done the work as what we did within Blender. So the same way we are doing the generation task within one computer, we can also do it in 1,000 of cloud computer, because in real project, time is crucial. So with this cloud generation, we can scale our generation process from 2,000 frames per day to like 100,000 frames per day. This is definitely not the limitation about cloud generation, but this is enough for our own project. Here is another view. Another view, more high and abstract view to understand this generation process is that in this computer environment, Blender can operate between Blender scene and some on-site resources to execute a lot of things and output the data. Exactly how Blender going to do this will be defined in this Python script. Great. Now you already know how to do the synthetic data generation work. What we have explored and what we have established is far from perfection. There are always something we need to improve. In the future, there will be some long existing challenges. The first one is the sensor simulation. That is to say, we need to be more accurately simulate how real sensor works, so we will get more realistic data. The second one is the realistic rendering. We'll need some cheap general rendering strategy for automatic generation. And here's the old world generator challenges we already had. And the simulation, yes. In the future, we might introduce Blender physics simulation into our data generation, because that will allow us to generate more data beyond visions. That will be very important, very useful for our AI training. And of course, there will be a lot of strange problems that I cannot foresee, as usual. But the solution is in Blender community. Firstly, we have this great software that we can do everything for free, and we can flexibly integrate it with our own working pipeline. We have 3D artists, we have developers, and we have scientists from all other areas. And we have some random people doing some strange things. And it turns out that's pretty much everything we need. People said that we human artists should work hard against this huge AI villain, because they are going to replace us. But let's try not to use this against perspective, because there are already enough division in this age. After all, there is a very funny Chinese word said, 打不过就加入. It literally means if you cannot beat them, you join them. And it makes a little bit sense to me. Finally, love and peace to everyone. If you are interested and want to get involved, please contact me.